And then I want to go on to dabbling more with Linux. So any questions before we jump into all of that? All right. Well, let's start with the ODPs. All right, so we're back to doing some string processing. The idea of ODP 414, you're going to write a function called mix. It takes 3 arguments. They're all character pointers. The first 2 are inputs, the third is an output. Okay, these need to be arrays of characters that are already declared outside of the mix function. Okay, when you're writing your own test bed code, declare these things as, character, variable name, bracket, some number of characters. In the test bed that you link with to assess, that's already done for you. All right, so these are character string, and then an output array that you're going to write the result into. And you can assume that the 2 input strings are the same length, and your goal is to just interleave them into an output string. So if A and B are 2 input strings, your output string should end up with A0, B0, A1, B1, A2, B2, and so on, all followed by a null terminator. Okay, you can assume A and B have the same length. That simplifies your code a little bit. And so if A and B have a length of 5 each, the output string will have a length of 10. Okay, when I say a length of 5, that's 5 characters followed by a null terminator. And the output string will have 10 characters followed by a null terminator. All right, so write your test code write your mix function in a file called mix.c. You can make your test bed in a main.c, compile it up in the usual way, and test it. Run a lot of test cases, okay? I do several test cases in here. I test for empty strings. I test for strings with a length of 1. I test for generic strings with, lengths bigger than 1. But I always test where the 2 strings exist. They're not null, and they're always the same length. Okay? So run your code through a bunch of tests. Try running multiple tests in a row, because sometimes your output will be affected by previous runs if you don't terminate a string correctly, for example. So test the heck out of it. Once you're sure that it works, go ahead and link it in with the test bed. Sort of the usual drill there, and go ahead and assess it. All right, and how do we do this? It's pretty much the same thing as your previous ODP. You're building an output string. So easiest way to do this, right? Have an output location that you initialize to 0. Go through each character in both of your strings, and since A and B have the same length, string length A, string length B will be the same number. And I'm only going to go less than. I'm not going to go less than or equal to, because I don't want to deal with the null terminators in here. I'll deal with it at the end. So basically, take A bracket I and put that into, your output at the output location. Increment your output location, and then take the same character from I, put that into your output string, bump up the output location, And you can do this without an output location variable. You can figure out these indexes from I itself. You're welcome to do that. It's a little more work. It's a little more that can go wrong. If you want the most straightforward way, I think it's probably just the same thing we did in 452. Have an output variable, and every time you add something to the output string, save it at the output location, bump up the output location. Okay? This will serve you in a lot of different situations. Being able to build an output array like this. When you're done, add the null terminator. And where do you put it? Well, the way I'm interpreting these variables, outlook is always where the next character is going to be stored. So this is where the next character is stored. You always want to have a sense in your mind what these variable means. Something more precise than this tells me where to save stuff. Okay. Is it where I save the last thing? Is it where I'm going to save the next thing? Do I have to increment it before or after I save? What is its value when I finish my whole loop? Right? Those are all based on how you're interpreting this. And you can treat it a number of different ways. You could make this where you stored the last variable. You can make it where you're going to store the next one. And if you've done 270 and you remember stacks, this is a decision with how we interpret the stack pointer. All right, but this is not a stack. So I'm thinking of outlook and this as always where the next character is going to be stored. So when I finish my loop, outlook shows me where the next character will be stored. That's where I'll plunk down the null terminator. And then you should be good to go. So in this case, there's no declaring a temporary thing. There's no doing string copies or anything because we know that this character pointer out, this array, is where we're going to store our output information, and we're guaranteed this has enough space to store A and B interleaved. So it's at least twice the length of these plus 1 for the null terminator. So we're copying the first from each input, the second from each input, and so on. Yes. So your output string would look like this. First element would be A0, next element would be B0, next element would be A1, followed by B1, and so on and so forth. So just to play out an example. Say I call my mix function, my first string is hello, my second string is there. My third argument is just an output array. Here's what out's going to look like. It's going to be H followed by T, followed by E, followed by H, followed by L, E, L, R, O, E. And of course a null terminator on the end. All right, or a simpler example, if I were to mix the strings 1, 2, 3 and the strings 4, 5, 6, my output would look like this: 1, 4, 2, 5, 3, 6. All right, everybody good on that? Yeah, and I've got my chat window set up to non-public. Let me reset that. Yes, that is left over from Friday's test. All right, cool. You can chat to everybody. Thank you. All right, so that's ODP 414. We've got a series of ODPs coming up this week. We've got another one which will be a string manipulation, and then one that does a little calculator program. getting easier and easier to do these because they're all kind of dealing with the same things, which are string manipulations, and you've already done a bunch of that in homework 6, the high-low game. All right, so let's talk about homework 6. So the big programming assignment. So so I was really happy with how successful people were in this. In almost all cases, this game played really well, and the grading was straight from the assignment prompt, which we already talked about when we gave out the assignment. But basically, these were the things that I tested, and so let me just show you the kinds of things that I was checking for. Actually, let me do this on So I downloaded, I made sure that you had all the pieces. I don't have a README in here, I have it in another directory. I would do a make to make sure that you could make your file. And then I would do a make clean and make sure that that removed everything. Then I would do a make again, and then I would do a make again and make sure it said make was up to date. And then I touched one of your files. So touch just updates the access time on it, so it looks as if I change predict.c and then I say make again, and it compiles predict.c and then rebuilds the executable. So that's the make file part of it, and it just needed to do all of those things. But you can run those tests yourself and see if that works. And then I ran the program without any arguments. I'll take apart my make file in a little bit when I go through sample code. Let me show you how I tested it first. So I would run main without any arguments. It should say between 0 and 100, either here or once the game starts. Should say 0 to 100. Then I would run this with a single argument, and it should say 0 to 200 somewhere in here. And then I would run it with a pair of arguments, and it should say 200 to 300. And then I'd add another argument, and that should be an error. And then I'd make one of these numbers not legal, and that should be an error. And if all of those worked, then I gave you credit for correctly error handling command line arguments. Then I ran main from 100 to 106, which should take 3 guesses. And then I tried 100 to 107, which should take 4 guesses. And then if all of that was working, then I went ahead and I started playing the game. So it started 50, and I kind of changed this up depending on how I was playing. But at some point I would start doing things like just hitting enter, or typing something that started with L but wasn't just an L, or an L with spaces in the beginning, or something totally random. And I would try these things with different variations to make sure that you were parsing exactly an H, an L, or a C followed by the enter key. And then I would go ahead and I would make sure that you responded correctly when I told you that the game was correct. And then I would bring it in to as close as possible to the right answer, right? So I could say 95 was low. I was thinking of 96, right? And then tell you that that's correct. And then I just tried some cheating options. And at this point it should call a cheat. And then I tried testing the edge cases, so drive it all the way up to 100. And it should guess 100 correctly before saying it's cheating. And then I drove it all the way down to 0, and it should guess 0 before it's cheating. Almost everybody got that perfect, which has never happened before. This is the part that always trips people up when I do high-low, is they write their code in a way that doesn't let you actually guess one of the extremes, like 100 or 0, or they call cheating too soon, or they guess a number twice before they detect it's cheating. And almost everybody nailed this perfectly, which was really good. And then I looked at the README, I looked at the source code and just kind of eyeballed it. I checked for the .h file to make sure that looked reasonable, and that was basically it. And then the comments in Canvas they're kind of flipped. Like if there was a problem with the program starting when no arguments were run, you got a message that said program starts with the correct range when run with no arguments, parentheses -5. So I was showing the tests, the criteria that were supposed to be satisfied that I found issues with. All right, so that was basically how I assessed, and you're welcome to run that on your own code, and if you have questions about it, let me know. Some people left me README saying basically they ran out of time, or they didn't think this would take as much time, and they started too late and stuff like that. So if that's what's going on, right, and you know how to correct that, that's great. Carry on. If you weren't able to get code that could compile and run, and you're not sure what was going on, right, definitely come and talk to me. Catch me in office hours. We can go through your code. We can figure out what was going on and so forth. All right. So yeah, let me clean this. All right, so let's take a look at just a sample of the code. So if one more files done. So let's take a look at the makefile, and the only extra thing to answer the question in chat, I'm going to talk about variables for the makefile, but we're not going to get into anything deeper than that. I basically want enough makefile know-how for people to be able to create a makefile so that they can say make and it'll build the project fairly efficiently. But let's take a look at some of this. So here's my README. And it's just, my name, the date, the class, and then a synopsis in my own words of the program, which I could have ripped off from the assignment because those were my words. But, what the program does, basically how it works, it's divide and conquer, splits in half, predicts the number of guesses required, which is approximately log 2 of the range of numbers, detects cheating by seeing if low is ever bigger than high, and then a synopsis of how you can run it. 3 possibilities and the requirements. Description of the make file, so you can either say make clean or you can say make, and the executable is called main. The only thing I wanted in your make file, the only thing I insisted on in your make file was your name, date, class, and a description in your own words. But this was, if I were turning this in for a class, this might be what I would put in the make file as kind of like, here's what this is. If you're curious what's in this directory, take a look at this file, right? It gets them started on the basic idea, and they can say, yeah, I'm interested in this, or no, I'm not. So my repo had the README, it had the .c files, it had one .h, and it had a make file. All right, so let's take a look at the make file. And so the one slightly fancier thing that I did here was, instead of just hardwiring GCC, I used a variable, which I just called it CC, and I set it equal to GCC. Anywhere in my make file where I say $paren variable name, that gets replaced with the value of this variable. So if I wanted to compile with something other than GCC, I could just replace this one line here, say CC equals something else, instead of rewriting all of this code. Okay. This also happens with flags I want to put on the compiler, and in particular I'm thinking of debug flags. So when I'm developing, I might want to have a GCC-G, all of this stuff to put debug information in. But typically when you submit, a final project, you don't have the debug information in there. So rather than going through and editing my make file, which is, error prone, I can just set cflags equals -G, And now next time I say make, it'll do GCC-G. I'll have all my debug info. And we'll see that in a few minutes. All right. So most people's make files look more or less like this, really good. You know, the first target is main, and it needs the .os, and there's the compile line with the -lm because I use the log function. And then the ways to build each of the .os, which just depend on the .cs, put those together. Main depends on the include file as well as the .c file. But again, the include file is not listed in the GCC line. And then the clean does an RM. Yeah, I did an F just to suppress error messages. So -F is force. It will remove files that are write protected, but that you actually have the ability to change the permissions on. It'll go ahead and just remove them without comment. And if a file's not contained in there, it will just continue silently. So if I say make clean, even though there's nothing to delete, it doesn't give me any messages. Alright, so main.h is just function prototypes, so it's just 3 functions. GetAnswer.c, so read an HL or C answer from the user who's already been prompted, right? So this doesn't prompt initially. And return that character. If it's not a valid input, prompt and continue. So I just do an infinite loop, and I note that once a proper response is received, we'll just return out of this loop. So do an fget. I remove the null terminator just because we talked about it in class. And so now if the person types H followed by enter, I expect this string buffer to be exactly the string "H. So I chose to use string compare. You can do this by comparing elements instead. So if buffer string compares to H, then I return an H or an L or a C. Otherwise, print a prompt, go back up. So that's the get answer. Intro.c is kind of a silly function, but I wanted it to be kind of a warm-up to breaking your code into pieces, because you don't pass anything to it, you don't get anything back, you just have to call it, but I wanted it in a separate file, so it's a chance to, you know, practice putting something outside, compiling it together, and so on. And so it just prints a few things. There's nothing too exciting going on in there. Predict, basically just, you know what it does because you wrote it. Tells you how many guesses it's going to take. And the logic here, and I don't know if this is right, this is how I decided it should be, and then I tested it and it worked. The number of possible guesses you could make is 1 more than high minus low. Right? So if you're guessing a number between 1 and 2, it's not 2 minus 1, it's actually 2 minus 1 plus 1, 2 possibilities. So that's the number of things you're trying to choose from. And log 2 of that shows you how many times you can cut that in half until you have fewer than 2 things left. You might have 1, or you might have 1 point something things left, which will still mean 1 thing left. And then when you've got this narrowed down to a single number, you have to actually make a guess for that number. Right? You know the number 17, you have to say, is it 17? Well, that's a guess. So it's 1 plus the log 2 of this stuff. Alright, so that's the range, that's the log of it, and then you add 1. And then only thing left is main. And so this is a bigger main program than it might be. You could take a lot of this and throw it into other functions, but I didn't want to go too overboard. So you know, include main.h, and I said it just does function prototypes. Error is just going to print a usage message. There's our main program, always declared like that, or, you know, car star argv bracket bracket. This is for picking up extra stuff. A note here that if you're worried about buffer overrun issues, you could truncate the arguments from argv if their length is bigger than, you know, the size of this extra stuff. And so I started off with just low and high. This is going to be the range over which we're playing the game. And then I parse the arguments and possibly change the values of low and high. So if argc is 2, we've got main, 1 argument. Okay. So the person is trying to specify a high range. So the usual way to parse, right? And I'm going to say when you want to parse an integer and it's supposed to be a legal integer, this will almost always work for you. Right? Do an scanf %d followed by %s, not %c. Throw the first thing into an integer with the address specified. Throw the second thing into a string. Make sure it returns 1. If it doesn't, something's wrong with their argument. Print an error message and just exit. So return 1. All right. If argc was 3, then they said main, low, high. So I have to parse 2 arguments. Parse argv1, parse argv2, and they look exactly the same as up here. And if either of those scans fail to return 1, something's wrong with the number. Print an error message, return. If argc is bigger than 3, too many arguments, just print an error message and return. And I don't need else's on here, because if argc is equal to 2, it's not equal to 3, it's not bigger than 3. If argc is equal to 3, it's not equal to 2, it's not bigger than 3. Now I could go else, 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 and my code gets more and more indented, and then when I have to undo all of those, there's more and more of a chance of error on my part, especially if I have to go in and change something or add another statement or something like that. So personally, I try to keep indenting to a minimum, right, unless there's a good reason. Possibly a slight inefficiency by forcing it to evaluate argc 2 more times when in fact I know those statements are going to be false. I would prefer to have code that's easier for me to read at the expense of the CPU doing a little more work. That's just me. So if it's equal to 2, if it's equal to 3, if there's too many arguments, error out. Otherwise, we've got high and low set now, either because there were no arguments, 1 argument, or 2 arguments. Check the range. If low is negative, or if low is bigger than or equal to high, that's a problem. Print an error message, exit out. All right. So all of that is preliminary to the gameplay. Print the hello message, right? That's the intro function. And now we're ready to play. So prompt the user to think of a number, do an fgets to let them hit an enter, and then make our prediction. I will guess your number in at most %d guesses and call the predict function. Low and high have already been set up, right? So, and when I asked them to think of a number, I used low and high to print out the range they should be working in. Alright, so print out the prediction, and now we're ready to start playing our game. So guess is going to be, the current guess that the game makes. Guess number is the number of the guess that's about to be made. Okay, so guess num, the sense in my head is it's the number of the guess that is about to be made. Okay, the next guess. And then done is the way we're going to kick out of our while loop. And then here's our whole while loop. So while we're not done, make a guess. It's high plus low divided by 2. Print out guess %d. So guess number, guess num. And after I print it, I increment it. And then print out the guess. Get the answer. If the answer is high, adjust your high based on the guess. If your guess was low, adjust low based on the guess. Otherwise, it was correct. I don't have to check to see if answer is C, because if it's not H or L, it's going to have to be a C. That's what get answer guarantees for me. And so I just set my done flag. And then I check if low is bigger than high. And if it is, we detected cheating, set the done flag, print a message. And then when we come out of the while loop, I just say, thanks for playing, and exit. And then there's one function in here, which is just the usage message, which tells you how you should run the game. It just shows you legal ways of executing this. All right. So I saw lots of different ways that this was written, and lots of ways that worked well. So this was just an example, right? I still want you to figure out your own style, figure out what makes sense for you. I did not see a lot of commenting, and I never said on this list that there'd be a deduction for not commenting, so that was my bad. But did not see a lot of commenting. Got to comment your code. Okay, most teachers will ding you. They may give you an automatic 0 if it's not commented well. So make that a habit. All right. So if I play this game and I think of a number, and let's say I'm thinking of the number, I don't know, some number. Let's say I'm thinking of the number. All right. So something went wrong here because I told it 24 was low, but down here it guessed 23. And if 24 was low, it should never have guessed 23. And now we got a bigger problem, which is it keeps guessing 76. And I told it 79 was high. Told it 75 was low, it guessed 76, but it's not going above 76. Alright, so let's go into our make file, let's add a debug flag. And yeah, it took 11 guesses. So let's make this. Now if I say make, it tells me, hey, main's up to date. Right? So this is where I can say, yeah, but I want to recompile everything because I just changed the compile flags. So I'll say make clean, and I'll say make. That recompiles everything. You can see it put the -G switch in there. So I should have good debugging information. And now let's go gdb main. And let's list our code and find a good place to stop. So let's stop right here where it's about to make its guess. So let's say break 62, and let's say run. So think of a number, hit enter when you're ready. Okay. So I'm just going to continue the first few times. I'll say 50 is low. I'll say 74 was high. I should have written down my test case. Alright, so it's guessing 66, it's guessing 69, it's guessing 70. It's guessing 71. It's guessing 71. Okay, so I think I reproduced my test case. So it's guessing 71, and I'm telling it 71 is low, but it's not changing its guess the next time. All right. So so let's go back up here and look. So let's look at low. Low is 70. Let's look at high. High is 73. So let's adjust our guess. So our guess is 71. Okay, that's reasonable so far. Low is 70, high is 73, guess is 71. That's good. It's going to print out, guess %D, is that high, low, or correct? So I'm going to execute that statement. And you notice it didn't print anything. Right? Now I've told you when it shows you a statement here, that's the statement about to be executed. I said next, which should have executed this. Why didn't it print anything? Because there's no new line at the end. And remember, things like print are what we call buffered output. When you say print something, it doesn't necessarily get printed right then. In this case, it got queued up for printing. It went into an output buffer, but we're not going to see that output buffer until we print a new line, which forces it to flush that out. Or we call a function called fflush to say flush that stream, or we request input. Now our getAnswer function is going to ask for input, and that's going to force this message to appear that was printed right here. So I'm going to say next. Now if I said step, it would go inside my getAnswer function, but I'm not worried about my getAnswer function. So I'm going to say next to just execute that call and come back to the debugger when it's done. So it prints out the thing that was printed up here, and it's waiting for me to say high, low, or correct, and I'm going to say low. And now we're back in our program. Presumably we just finished this call. So if I print answer, answer is equal to L. Alright, so now we're saying if answer equals H, and that's not going to fire. Now it's going to say else if answer equals L, and that is going to fire. and this is going to set low equal to guess minus 1. Well, what's our guess right now? It was 71. This is going to set low equal to 70. Well, what's the current value of low at 70? So this is not going to change the value of our low range of our guesses. And that's why it keeps guessing, right? So I made a typo in here. So I look at low is 70. What low should have been was guess plus 1. Guess was 71, low should have been 72. So I can say set low equal to 72, and now I can continue, and you can see, let's continue. So now it guesses 72 instead of 71. Alright, so that tells me that's probably where my error was. And I'm just going to exit with Control D, and GDB will warn you if you got something running. I'll just say yes, quit anyway. And so if I go down to low equals, this should have been a plus. So I change that, I remake my program. Well, let's go ahead and do that. So change that, I make it, I run main. I say that's low, I say that's high, I say that's low. Now it's guessing correctly. It got past 71, it tried 73, it's trying 74. If I tell it that's wrong, it's going to call me on cheating because 75 was too high, 73 was too low. Alright, so there's a GDB example. Alright, so questions on homework 6. So, oh yeah, get answer. So a lot of ways that you could code this. So the way I did it, I stripped off the new line, and then I expect my result from fgets to be either the string H, the string L, or the string C. If I didn't strip off the new line, I could have string compared to H backslash N, or L backslash N, or C backslash N. You could check to see if buffer bracket 0 is H and buffer bracket 1 is a new line. That would work too. Or you could strip off the null terminator and see if buffer bracket 0 is H and buffer bracket 1 is the null terminator. There's different ways you could do it. A number of people tried to do this by using scanf. Scanf can be finicky. Okay, scanf has very particular rules for doing things. If you try to scan something with a %C, it will give you whatever is there. If you try to scan with a %S, it will treat white space as a separator, and a new line is white space. So that can make things a little weird. So that's but it is doable, and some people were totally successful using scanf. Alright, so yeah, if you have questions about your code in particular, definitely come by office hours. So I'm in office hours 7 to 9. And so a few people lost points because in the make clean part of their make file, they removed everything .o, which the prompt specifically said do not do that. I wanted you to remove the particular .o files that your make file creates and that you need removed to clean things up. The reason being there might be other compiled code in this directory, and if you just remove star.o, that's a little heavy-handed. So so the assignment said don't just remove star.o. So if you did that, you lost the make file points. All right, other questions? So this is an example of a type of algorithm called divide and conquer. Um, you'll take, entire courses on algorithms at a university that study different classes of algorithms. There's greedy algorithms. There's divide and conquer algorithms. There's whole classes of ways of approaching solving problems. The high-low game that we coded, that's an example of divide and conquer. And the basic idea of divide and conquer is you're trying to solve some problem. If you can split that into a smaller problem and then solve that, and then use that solution to solve the bigger problem, that's typically a divide and conquer structure. And sometimes, it's just pairing your space of possible solutions, just cutting that down. In the case of high-low, that's what we do. We say guess a number between 0 and 1,000. Well, after the user's first answer, we have a smaller problem. Guess a number from 0 to 499 or from 501 to 1,000. And each of those is half the size of the original. We only have to solve one of those. There's other divide and conquer problems where you would have to solve both of those smaller problems and then put the solutions together. There's a lot of sort algorithms, for example, that work like that. But that's also a divide and conquer. And we'll play with a lot of these in 222 and 223. We'll play with merge sort and quick sort and all these other things that are divide and conquer. High-low works that way too. When we get into 222, we'll start playing with recursion in earnest. If you're in 215, we've been talking about mathematical induction, which is the kind of mathematical version of recursion. Let me show you a really simple version of high-low. This does not have any of the fancy error checking, the command line processing, the interactive dialogue, the checking for HLC, and so on. This is just the guts of gameplay. And this just plays from 0 to 100, so I don't know, let's just think of a number like 60. Right? So that's the guts of high-low gameplay, right? And this is a really short program, right? This is the whole thing. And it's built around a function called play that takes two arguments, low and high, and it plays the game. And how does that do that? Well, it makes a guess. It asks you if it's high, low, or correct. It gets an answer from you. And then if you said that the answer was high, and so I'm just checking the first, character of your return. If the guess that the computer made was high, then you know that the number is somewhere between the low range and the guess minus 1. And it says, okay, well, I'm just going to play a new game. I'm going to play a game of high-low between low and guess minus 1. But if the guess the computer made was too low, then it knows that there's no number from the guess on down that could possibly be what the person was thinking of, because the guess was too low. So it just says, okay, I'm just going to play a high-low game between guess plus 1 and high. And if the answer was not H or L, we assume it's correct. It doesn't have to do anything more. It's done. It just returns. And this is recursive, right? Because this function play that's being called is actually the function in which that call is. Okay, and that can take some brain warping to get your head around. But this is classic divide and conquer, right? If you're playing between low and high, it's going to end up playing another game either between, low and the midway point or the midway point and high. And there's almost no code to write in here. The only real piece of code here is, make a guess in the middle and then play a new game. But it totally works. And you can throw in cheat detection without too much more. So there's the version with cheat detection. And basically, play now returns a number. It returns -1 if cheating is detected, 0 if the game plays normally. So I play the game from 0 to 100, and if that comes back with -1, I just say, hey, there is a cheat going on. And now the play function has a first case. This is our base case, if you like. If low is bigger than high, return the cheat code. Otherwise, make the guess, ask the user, get the answer, and then here, if the guess was too high, I say play the game between low and guess -1, and whatever that returns, return that. In other words, if this game finishes normally, just return, that this original game finished normally. If this sub-game returns that there was cheating that happened, then this game will also return that cheating happened. And if the person says correct, we return 0, which says, the game finished normally. And so up here, this call to play returns either, 0 for normal or -1 for cheat. And again, classic divide-conquer structure. Here's our function. Here it makes a call to itself, but with a smaller range of arguments, a smaller problem to work on. So we'll spend most of 222 playing with recursion, okay? But it's just kind of a first glimpse of it. And it's pretty powerful, right? I mean, 22 lines, and I've got some white space and some formatting in here. And there's a whole high-low game that actually detects cheating, and, we'll play between any two numbers by just putting those in the initial call to the play function. And that's kind of cool. All right, so questions on any of that? All right, so tomorrow we'll start talking more about Unix stuff and Bash scripting, and we'll talk about the next ODP also. All right, have a good one. I will see you next time.